Welcome to my channel AI Basics with AK. Here we are for new episode on Lambda function. Why waste time? Let's jump to our episode 12, Lambda functions. Topics for this episode: regular function versus Lambda function. Use of Lambda function.
So in the last episode, we have explored what is regular functions. Now we will see a lambda functions, which is a simpler version of a regular function. So lambda functions are used when the complexity of the regular function is very less, like a one-liner function, like adding numbers, very simple functions. Then it is wise to use lambda functions because there is no explicit definition of a function that we have to write, which we'll explore in the further slides.
In this slide, we will explore both regular functions and lambda functions in sequential manner.
So you know that this is a regular function definition that we have seen in the last episode. Coming to lambda, the lambda definition is like an anonymous function because we will not use any definition while defining a function because we have to express everything in a single statement. So instead of that, we can actually write it simply by mentioning a keyword lambda colon and print my first function, and you can assign this to your my first function, which is actually we are defining it in your earlier like how we have defined it here. You can actually assign that piece to my function and you can just call it in this way. Automatically you will get the same output that we have seen it here as well as it here. Let's see the similar functions in a sequential manner, which is one we will see it on regular functions, and then consecutively we'll see a lambda function definition very quickly. Here you will see the sum of two numbers here, number 1 and number 2, and we are adding the two numbers total, and then we are returning the total. All these things can be simplified by just mentioning lambda, and then these are my two arguments x comma y, and then we are summing up these numbers. So we are mentioning it as x plus y, which automatically returns this computation and then gets assigned to this when we dynamically pass these values. The same thing that we can explore while defining for the area of the circle as well. Here we are returning 3 pi r squared. Similarly, you can mention it in the same way, lambda, and then this becomes the radius is generally the argument that passes into your lambda function. Here earlier we have seen the arguments as x and y, which passes into your lambda function. Here we are saying radius, which is actually the argument that passes into your lambda function. So whatever the arguments that we have to pass on to your lambda function resides on the left side of the colon function. On the right side of the colon function, you can think that whatever the one-liner function that is there, like x plus y or 3 pi r square, etc., you can mention it on the right hand side. Even if there is a simple if and else statement as well, you can easily write it out in the lambda function also. But I don't recommend it because the readability of the function loses if there are more nested if and else statements. So I recommend to define a function, mention it out very clearly with code indentation such that when somebody sees our code, it becomes very simple. On the other side, if it is a simple 3 pi r square or x plus y or something very simpler, I recommend you to use the lambda function because explicit definition of the function, you can reduce the number of lines of your code. It reduces in generally, rather than defining it in 2 lines, you can reduce it into a single line. That's how you can write it, the code in a lesser lines of code. So here as the last sum of numbers, earlier we have defined it as an if and else. The working of these things, everything you can go into your last video. But here the same if and else, we are passing it out here as if n is equal to 0. Here this is little bit You have to remember, if n is equal to 0, we are saying it is 0. Else, we are saying it is n plus so and so, so and so. So this construction of if, and then like this, and then else, and then like this, is little bit complicated for a people who follows a structured code indentation, but it's the same way that we use the for loop in our list comprehensions that we have seen it out in our previous to previous episodes. So let's see a couple of more kind of a things, such that the entire working you will enjoy the lambda functions kind of a thing. Here you can see that we are defining a function is even numbers, and then we are returning a function whether that function return whether it is 0 or not. So using this, we can always say, okay, is even, then it gives an output whether that it is true or false. However, instead of 2 lines, as we have seen it in our previous slides, we can use a lambda function directly by mentioning it in a single line kind of a thing. Even instead of this, you can actually substitute this entire lambda, this entire code directly here. This will even save one more line, because the entire code computation and everything can be stored into your RAM if you have a better RAM kind of a thing. Now we have seen these computations of my sum 1, 2, 3, 4, 5, and then the different arguments. Here we are seeing it out in number of different arguments. The same thing, this is a different example which I will showcase it. Earlier we have, in the previous episodes, we have defined the number of arguments as number 1, number 2, or number 3 kind of a thing. And then here we are using a dynamic arguments. If you can see it out here, dynamic arguments. It means we don't know the number of input arguments that goes into our function. So in that case, we can use an asterisk and arcs where there are dynamic computation. Here you can see it out where I don't know the number of input arguments. In that scenario, you can pass this entire pieces as a list or an arguments kind of a thing, and then you can total all these numbers using the simpler function. And then also, if there are only 2 numbers or 3 numbers or 4 numbers, you can use only single function instead of actually defining it in multiple functions. Also, you can define like number 1 and number 2 as a predefined assignment, like 2 and 3, and then you can pass multiple arguments. So when we are doing in such scenarios, so these both functions are in generally same. You can use sum of arguments, or you can use etc, etc. You can use for loops, etc. Just the demonstration between this and this, both outputs are one and the same. But however, I'm more interested in explaining these outputs. When I'm just printing my sum, only these 2 numbers like 2 and 3 are getting consumed. So automatically these are, since these are predefined, these numbers gets added 2 plus 3, which is 5. When I'm passing extra like 1, 2 and 3, even though these are predefined as 2 and 3, this gets overrated into 1 and 2, and these 3 numbers gets added, which is 1 plus 2 plus 3, which becomes 6. When I'm passing 5 into 6, which is nothing but 30, 30 doesn't goes into arguments, but instead it gets reassigned into my number 1, because this is my first argument. So this becomes 30, and the default argument of number 2 is 3. So 30 plus 3 becomes 33. Say for example, if I want to just mention that 30, then and I do not want any other further arguments to be 0, you have to explicitly mention it as 0 here. such that only this computation gets passed out into our further whatever that computation is. This is just a demonstration of how you can use a predefined functions and arguments. This is especially you will realize these things when we do further modeling while doing hyperparameter, because by default when we call say linear regression, it uses some default numbers that are already defined. It say for example, if you want to fine tune it, you have to test it out with different variants of how your output becomes, and further you can optimize your modeling, which I think you will appreciate when we go into our data science series. The same things that we have seen it is in our function can be expressed in a simple way using lambda functions also, where lambda, these are my arguments which are on the left side of the colon, and then on the right side of the colon is my simple return statement, which is number 1 plus number 2 and sum of all my arguments. Beautiful, right? Similarly, here you can see the same thing where I'm just printing my square of the numbers. I can do it using list comprehensions. The same list comprehensions can be passed as a written statement as well in the lambda. So this becomes very simple. When I'm just printing my squared numbers, automatically the output becomes my list comprehension output. Somebody can say that, okay, why to use this complicated lambda function when you are actually writing the list comprehension. I'm just demonstrating the usage of a list comprehension because lambda function that you can also written in this way. But this is not an optimized way to do it. So finally, why we need to use lambda functions and where it is used. Syntax, okay, it's very simple statement. There is an arguments which we have seen it out, and then there is an expression. Left side of a colon is this is a colon which separates both our arguments and expressions with a keyword lambda. So the lambda, there is an arguments, and then so this is very simple definition of a lambda function. There is no explicit written statements. Ideally, the entire written statements, whatever we want to do it, we actually represent in our expression. Ideally, the limitation is that we cannot complicate our logical flows, logic or control. Like say for example, in while defining a function, there can be defining. We have seen in inner functions also. However, while using lambda functions, we cannot have an inner lambda functions at this point of time. However, we can write it out, but it is wise to limit those usages, because readability of your code will get lost. So how often is used? When we are using a simple data manipulation activities, okay, then we use it very often along with usages like map, filter and reduce, which we will learn in the next episode. Okay, because this lambda functions is actually a foundation to perform some of a beautiful data manipulation activities using map, filter and reduce, which I love it while using especially a pandas data frame activities. And then especially if there are multiple rows while performing a while performing data manipulation, it is often to use lambda functions to create an explicit functions instead of creating an explicit function. What it means is that if there are multiple columns in a data frame, assuming our data frame is nothing but an Excel sheet, and then if there are column 1, column 2 and column 3, and then you want to calculate something column 5 using 1 plus 2 plus 3, instead of defining a function, you can actually write this lambda function and then calculate these numbers on the go by adding all these 3 numbers using lambda functions. And then the code becomes a little bit light because you are writing it in a less number of quotes. And if it is a very simple activities like 1, 2 plus 3, the code readability also will not be lost. That's it. Thank you. As usual, If you want to explore the code, you can just click on the Google Colab link and then explore this entire code and practice as per your convenience. So before jumping into our demo session, as usual, let's jump into our homework and let's explore what's in our homework. It's very simple. I think it's homework 12, which I have not changed it. Yep, this is homework 12, and then you have to just rewrite this lambda, this simple code into your lambda function, which we have seen in multiple examples. I request you to do it and practice it. And similarly, just we have seen an example of squaring. Here I'm requesting for cube of a square root of these numbers. Understand? Cube of a square root of these numbers. This is just not just for an exploration of lambda functions, but also for understanding this terminology of cube of square root. Sorry, there is no demo session for this episode. We will have the combined demo session of this episode as well as the next episode in the next episode using map, reduce and filter commands as well. In that way, it becomes a little bit more comprehensive, and then I can do some value addition in terms of while exploring our demos as well. Else it becomes just simple replication of what we have seen it on our slides, which I recommend you to practice it out by using the Colab link, which is already there on the slides. See you in the next week then. If you like this episode, please give a thumbs up and do share it, and please do subscribe. It helps me a lot. Thanks a lot. Bye bye.